Machine a blended rib. After completing this video, you'll be able to use 3D flow, use 3D scallop, and identify stock removal. In Fusion 360, let's carry on with our 3-axis sample Op2 dataset. We've used our 3D adaptive to rough and semi-finish our part. We've used a 3D scallop to finish both the bowl and dome features, and now we need to focus our attention on this blended rib feature. Now, this blended rib feature is a feature that is going to require a couple of different strategies. We're going to think about this in 2 different steps. We want to focus our attention first on this outer face and evaluate a flow toolpath. Then we want to take a look at how well the scallop toolpath does, finishing all the geometry as a single operation. So from our 3D menu, let's select 3D flow. The flow toolpath is something that can be used on complex geometry, and it's controlled based on our face selection. This is an important distinction because if we select a large and a small face, the number of stepovers can be drastically different, and the surface finish going across those faces can be compromised. But let's go ahead and start by selecting our 1/4-inch ball end mill, and for our geometry, we're going to select these 2 faces. The first thing to note is the direction of the red arrows. This is the UV direction, or the direction of the surface ISO lines. We want to make sure that the red arrows are pointing in the direction we want our tool to travel. Next, we're going to move on to our passes section. The passes section looks a little bit different than some of our other toolpaths. Using a flow toolpath is going to require you to indicate the number of stepovers, while other toolpaths will give you a stepover amount or a cusp height that you can use to drive the toolpath. In this case, we're going to indicate 15 stepovers and say OK and preview the toolpath. When we take a look at the results, you can see that we're getting really large cusps across the part. And if I use F7 to bring the toolpath preview on, we can see just how the toolpath is moving. The tool does stop when it gets to the end of these surfaces, and it performs rapid movements to get to the next section. Let's right-click and let's edit our toolpath and increase the number of stepovers in the passes section to 30. Once we increase those to 30, we now have a much finer resolution stepover. You can see that we are cutting down into the bottom of the part slightly, and that's because we haven't finished off our flat areas. That's something that we'll approach in just a minute. So with a toolpath like this, if we were to edit the toolpath and increase the number of faces we selected, for example, if we wanted to include these small faces on the side, notice that we're having problems with the direction of the ISO curves. And if we use F7, one thing you'll notice is that the number of stepovers on that small triangular face is going to be 30, which is equal to the same number of stepovers on this large face. Because of that, we need to be careful when we're using the flow toolpath, and it really should be used or reserved for large surface areas or complex faces that are struggling with other strategies. So for right now, I'm going to right-click and suppress this toolpath, and then I want to focus on how the 3D scallop works on this case. We're going to select 3D scallop. Once again, we're going to use our 1/4-inch ball, and once again, we are going to use our avoid touch surface options. We could also contain it within a selected region, but using avoid touch surfaces is a good way for us to identify all the surfaces that we want to machine. I'm going to rotate the model to make sure that I do select that small triangular face. Let's go ahead and rotate to the other side and make sure that we grab all the faces on this side as well. Once we have all the faces selected, we can move on to our passes section. Once again, the stepover value is going to be driving the overall contour. So I'm going to reduce this to 0.001 for my stepover, which is relatively small, and we're going to say OK. We can see that once the toolpath has been generated, we have quite a few traces that we have on the screen, so I'm going to hit F7 to hide those. The resolution of the finished product looks pretty good, but it's always important that we take a look at our machining time. This operation alone is going to take 20 minutes because of that 0.001 step amount. And this is where we need to find a balance of surface finish relative to our machining time. Let's go ahead and edit the scallop operation. Let's take a look at our passes section, and instead of 0.001, let's take a look at 0.009 as our stepover. While that might not seem like a much larger number, this can have a pretty big effect on the overall machining time. When we take a look at this, you can see we went from 22 minutes to just under 2.5 minutes. So this can have a big effect, just making a small change to that value, and we still have a relatively good surface finish compared to the amount of passes and time we're spent machining. You can see that the scallop operation does take a different approach to the passes, so you will get some knitting lines or some seams between the different tool paths. Now, keeping this in mind, there are some potential changes, options, or things that we can do to alleviate those problems. So it's always a good idea to evaluate the different options that you have inside of your tool paths. There are feed optimizations and smoothing options that we could use as the tool goes into and out of rounded corners, for example, and smoothing operations that can be used to reduce the program size. By turning on smoothing, we can reduce the number of steps that we have for our curves. So those options can help the overall quality of your surfaces by affecting the way in which the tool goes into and out of those rounded corners, and also limiting the number of changes in direction that the tool is taking, which can also have an effect on your surface finish and surface quality. Keep in mind also that most of these strategies are available as multi-axis strategies. So if you do have the available access to 4th and 5th axis machines and the manufacturing extension, you are able to control things like the tool axis, the collision avoidance, and tool axis limits as the tool goes across this geometry. For right now, however, let's go ahead and make sure that we do okay this, and let's make sure that we save our operations before we move on to the next step.